I'm going to run everything here within Colab. The first step to load the data, I've already done all this, so it will show here, for example here. The first cell, I'm importing the pandas library, importing the Geopandas library, giving aliases to both, right? And loading, when mounting the Google Drive, it is saying that it is already loaded because I had already done this here. Testing to see if everything went well. Inside the drive, there is a specific folder where the data is. I saved this folder here in this variable, ESC folder. So every time I need to call the folder again, I just need to call the variable. It will be easier. Within that data there, when we download it from GeoSampa, it goes from 2003 to 2022. 2021 indeed. But in the folder, from 2017 onwards, it changes the name of the files. So for me to load all of them, I would have to change the name file by file. I ended up choosing not to do that now, because the interesting thing here is to see at least having some interval for us to do the test. And from 2013 to 2016 is enough. It's been 14 years, so we can take a general look, right? So here I created what I'm going to call the years. I created a range here to call it 2003 to 2017. I put this in the years variable below, so I will it will be the cell where I will import the files that are in XLS, which are Excel files, and convert all of them into pandas data frames and save them all within a list and so on. And the list within a variable, right? Later I will call all the data frames contained in that list. I will use looping to carry out these processes. Basically what I used in the entire script were loops to carry out each process. Here I created a function, imported them to work better here with directories. So I created a function that is to open XLS. It will receive the folder as a parameter, which is the variable that I already showed above, and the other variable, which is years, right? So inside the function, the first loop it has is to open XLS. It goes there. There's an empty list here where it will receive the first data frames. So I created the path here, used the ASCII folder to reference the path there, added the name that is common to all files, and used the year variable, which is what will vary there. Precisely each file will have a different year. All of them .xls. So you will receive a data frame variable here, which will be precisely the reading of this path there from the file, this variable above the file, right? And the folder, the spreadsheet, right? Because within this file, within this Excel workbook, each one of them has, if I'm not mistaken, 4 spreadsheets. The spreadsheet that has the data, effectively, the locations of the schools. So here I specify that the worksheet with index 3, which is actually the 4th worksheet, within the Python index, we know that it starts with 0, right? Year. This year field will use the year here that is being called in the loop, right? Each worksheet will be assigned a year, respectively. What I found more interesting, so I added the data frame that was created to the list. Then below there is another loop. This loop will take each data frame that was created here above and will filter the columns. And there are many columns there, and not all of them interest me, right? So I will only take the ones here that I'm referencing in order. Basically, there is a census sector, district code and such, and the type of that census tract and district code is not that useful. But here, crash class, pre-class, and crash class are important. Then I select all of them and create a new data frame with just these columns. I play here in the list. Then below here there is more loop. This loop will take this data frame with these columns of interest here and will filter it. What will be the filter here? I want schools just for early childhood education. So considered early childhood education is what? There is a preschool and a daycare center here. So I'm filtering here. It's either one or the other. So the operator here is or. So I filtered, added again, added to this list here, filtered. And these will be the final data frames. So at the end of the function, it will return the filtered data frames. Then here below I apply it. I create a data frames variable and apply the function I created above, referencing the ASCII folder there, which has that file address, right? And the years variable, which is corresponding to each year. Below preparing the data, I'm going to run it here, then I'm going to call. I'm going to create an empty list here again, and I'm going to run another loop. It will transform those data frames that are in the variable in the data frames list, transform into, I'm going to use Geopandas to translate a geo data frames. Here is the geometry column that it will create. It will use the coordinate columns, the E coordinate and the N coordinate, which in this case is not in decimal degree. It is in flat coordinate, which is interesting for the analysis. It already comes like this from GeoSamp, like UTM coordinates, flat. And it will be interesting because it already works in meters. I will use the buffer in meters, so the crossing becomes more interesting. And here I redesign the geodata frame for CRS 2000 and add it to that geodfs list.
GeoDefs.
Here I place that point of interest with the same coordinates that I showed above, but here using the first record of the first data frame. The 03 data frame. So I created a point from this selection. Then I create the area, which is a buffer. This area I convert here into key. When I buffer here, it created a geo series, but I need a geodata frame, right? So I created it here below and convert it to geodata frame. Here I plot it just to see if it's correct. It shows here that it's really a geodata frame, and here I just plotted it just to see if it's not to take much away from here, but here I had put this to check which CRS it was assigning, because the way I was saying that I was assigning the coordinates via input, it was not loading the correct CRS. Right now I commented because it is loading correctly. It's already converted into Jata frame. He's already carrying it correctly, which is what it is. 31,983, right? Which is CRS 2000. Let's go further down here to the analysis itself, right? So I'm going to create a new one here. Empty data frame here. Instead of a list, this time I create an empty data frame to receive precisely the year and the number of schools below. So I do the intersection using Geopandas to intersect that target region that I created up there, which is the buffer, and plus each geodata frame that is in the list of geodata frames. So I use the intersection predicate or inner to choose what is outside the buffer area, the annum here. It is receiving from each data frame the annum column, the first record of the first line there. The count then is the count of how many points there are in the intersection. Right? I add this activity, in fact, add the count, the year in the data frame up there, right? It's empty. So that's right. When I run it here, I already print a basic report showing a number of schools for each year. Below, I only generate the graph, even through Pipewad.
No.
I import it here and such. There are the graph settings, the titles, etc., the axes here. It's also another thing that for precisely this analysis that we can do through